Alright, this is the using objects activity. So in this activity you're going to practice writing some client programs that make use of some data types that someone else has developed. And you can download the zip file from the website, and inside of there is the using objects PDF, so you're feel free to just fill out the missing code on paper. Let me tell you a bit about what you'll be doing. Or alternatively, right, you can unzip. It also includes all the source code, so you can create your own Eclipse project and fill it in on Eclipse, which is how I'm going to do it. First of all, you're using two classes. The first is charge, and here's the public API for the charged data type. And charge represents a charged particle in 2 dimensions, so it has an x and a y position, and it has a electrical potential. And so you just have to use this data type. You don't have to develop it, and it has some methods like a constructor, and it can determine the electrical potential at some other point, and it can print itself out. Your goal is to finish this charged client, which simply reads in a distance from the command line and then creates 4 charged particles around the center, one to the east, south, west, and north, and then computes the electrical potential by summing the potentials of those 4 particles at some other location on the screen, 0.25, 0.5. Second program will be making use of the picture class, and so picture is a data type that is good at displaying images and modifying them. You can create a picture either from loading it from a file, like from a PNG or from a JPEG, or you can construct a completely blank picture and then go ahead and set all the pixels. And you can get pixel values, and you can set pixel values, you can show it, and you can also save it to a file. You'll be making a color separation client, and it's going to read a picture in the file name from the command line, and then it's going to separate out the red, green, and blue components and then display those 3 in their own window. And your final client is potential, and it's going to make use of both the charge and the picture data types. It's going to read in a file, so you've got a file with 9 charged particles specified by their x, their y, and their electrical charge, and then it's going to sweep over the 512 by 512 pixels of a picture object and set a color value based on the sum of the electrical potentials due to all the particles in the unit box. So go ahead and either work on that on paper or work on it in Eclipse, and then I will show you my solution. So here's the 4 charge client, and we're going to create a charged particle in each direction. So first we've got to create one to the south, right? So instead of changing the x location, we're going to change the y location. So to go south, we're going to subtract. Alright, so subtract the w from the y. Oops, I hit my mouse there. Alright, so there's south. If we want to go west, we take the x and we subtract the w instead of adding it. Okay. And if we want to go north, instead of subtracting the w from the y, we're going to add the w to the y. So that creates our 4 objects. Sorry, it's a little hard to get my comments all nicely lined up. We now have 4 instances of the charge class. So we have one object blueprint that's in the charge class, and you can look at the charge. If you want to know how things are implemented, you can look in here. But as a user of the charge class, as a client, you don't really need to know necessarily what the physics associated with calculating the potential, but you could go look at it if you like. We've got our 4 charged particles. Now we're going to call methods on the charged particles, like potential at. Okay, and we're going to calculate. This says object C1, charged particle C1, please tell me your potential, the potential due to you at this other point, Px, Py. We also need to calculate the same thing for the other 4 particles, so I can paste the code. Now, a common problem whenever you paste code is you forget to change something. So if I just go on and say, okay, all done, what have I forgotten to do? Well, I've forgotten to change. I really care about the charge particle at those 4 different, or the potential at those 4 different charge particles. So whenever you paste code, always be sure to look very carefully at your pasted code and change, because maybe you got to change something here, maybe you got to change something here. Not in this case, but always be careful. A very common source of bugs is to paste something and then not remember to change change things as appropriate. Sum the potentials. That's as simple as summing up these 4 local variables, v1, v2, v3, and v4. Alright, oops, didn't want to run that in the debugger. Now you can run it. Alright, and what do I have? Let's see what I've already set the run configuration. Alright, I've run it at 0.75, and at 0.75, this is, the potential at that particular point. Let's look at the next one. So the next one is color separation. We're loading a image from the command line, and we're going to create 3 separate pictures, and they're all going to be the same width and height. So the beginning part is just creating 3 objects of type picture, and they're all blank. We're then going to loop over all the pixel values. So our original picture was width and height. That's why we created these guys to be the same size. We want to loop over that, and for that original picture picked, we want to get the color at a particular spot. So notice whenever you're using an object in Eclipse IDE, it's smart enough. It knows pick is a object of type picture. So if I type dot, it's going to give me a nice friendly list of all the possible methods I can call. And some of these you don't recognize, like I didn't implement a hash code, but you're getting some of these just for free because all objects in Java have that particular method. But it's not something you're going to normally be using. Usually you're looking for the ones that are of the data type picture in this case, and like there's our get method, and so even as we type get, right, you can see it's helping us and telling us, oh, it takes 2 things, an integer I and an integer j. Okay, but that's just its help, right? My 2 variables I'm passing in, my local variables inside of this nested for loop, are x and y. This gets the color at that particular x and y, and then returns it, and we store it in this reference variable c. And then we can call methods on that color object, like get red, get green, and get blue. And notice these guys are returning an integer. And so colors could be, you can create colors using floats, as we've seen before, but you can also create them using an integer, and the way it works is it's an integer between 0 and 255. So a color object that's completely white would be 255, 255, 255, and one that's completely red would be some integer, and then 0 for the red, for the green, and 0 for the blue component. So this is the same, other than, remember, since we're pasting, we got to make sure we do everything appropriately. We've got zeros in 2 positions, and we've got the color in the other one, and we've got the right variable, and so on. So those are very common things that could go wrong when you paste code. And now we just need to show each of them, like so. Alright, and I haven't set a command line, but I've got our friend the don't panic PNG. So I can set that as the first command line argument to color separation. And now we run it. Okay, and it's launched it on a different window here. I'll just drag them over. And here are the red, green, and blue components of that original don't panic PNG. Alright, final program potential. Potential is making use of both the charge and the picture class. And it's loading a file, like I said, like this. Starts off with an integer, and that specifies there's 9 charged particles. So we're doing a very sensible thing of storing them in an array. First, we read that integer in from standard input. Now we must create the slots. We have n charged particles in the example 9. We need to create an array that can hold that many things. And that's how we do that. So you always have to new your arrays. This gets us our n slots. But remember, This line only creates n nulls. All right, there are actually no charged particle objects, no instances of this blueprint around yet. We've got to actually create those. We're going to loop over those 9 things, and we need to read in the 3 tuple. All right, there are 3 doubles. The first is the x, the second is the y, and the third is the charge. We read them into local variables x, y, and q. And now we must, in each of those slots, we must program the remote control. We must create a charged particle. And how do we, what kind of charged particle do we want? I want one at x, y, and q. All right, and that's because if you look at the charged particle API, I've got a constructor that takes an x, a y, and a charged particle, or a charge q. Next step, we've got all our data in our nice array A. We need to prepare a picture. And how big of a picture? Well, we're just going to use our default size like usual of 512 by 512. That creates a blank picture. Now we need to loop over all the pixels in that image. And so I is looping over the x coordinates, and j is going to loop over the y coordinates. It's a square, so this loop is the same other than we're using the variable j instead of I. So we've got our nested for loops, I and j. Inside of this we have even another, so we have a triply nested for loop, and what this loop's goal is to compute the sum at that x and y. So at that pixel location, what's the sum of all electrical potential due to all the charged particles? And so this is looping over those n charged particles. And what's the potential for that particular one? Well, we want to call it potential at method. All right, and we want to call it at x and y. All right, and so this has been completed for you, but what this is doing is converting. Remember, these charged particles in the charges.txt, they're living in the unit box, and we're looping over i's and j's that go from 0 to 511 inclusive. And so this is converting that big integer into a double that's in the unit box, which is where the charged particles are living. All right, and is that all we need to do? I think so. All right, we can try and run that, but of course it's not going to work because we need standard input. And let me open up, get my command shell open here. So here we are. We can run the potential, and we can send in the charges.txt file. And again, it opens in this window, but there you go. So that's an example of using making a client program that does something quite sophisticated and just leveraging the work that the people who developed the picture data type and the charge data type already did for us.